Okay, so instructions say solve each of the following to 4 decimal places when x is between 0 and 2 pi. It doesn't say this, but these are always the instructions. Exact value if possible, otherwise round, in this case again, to 4 decimal places. That's kind of the standard that we use. So what do we do?
Well, you have to use synthetic division.
Why?
Because you can't factor it.
So, but then we don't go to synthetic division. What do we do? How do you know it's not factorable first?
Because I tried it.
Oh, you tried to factor and you couldn't figure it out? So we didn't talk about this yesterday. I kind of avoided talking about it, but what's the trick that we have to determining if something is factorable?
It's the part of the quadratic underneath the root.
Yep. So what is that part? The part of the quadratic under, or the quadratic formula under the square root?
B squared minus 4ac.
B squared minus 4ac, and it's called what? What's its name? You don't need to know its name, but
Oh,
Katie?
discriminant.
Discriminant, right? So the discriminant, or b squared minus 4ac. So this question, again, this is a strategy we talked about yesterday. We could write it as 8a squared minus 8a plus 1. In which case, our a would be 8, our b would be negative 8, and our c would be 1. And so what is b squared minus 4ac? What does it work out to? 32, that's what I got as well. So this would be a equals negative b, well negative 8 is 8, plus minus square root of negative 8 squared, whoops, minus 4ac over 2a. We'd sub into the quadratic formula like that. But it's not a equals. In this case, it's not x equals either. It's sine x equals. Sine x is like our a. So if we're doing it for our actual question here, it's therefore sine x equals, and again, if you, as long as you show this step off to the side somewhere what b squared minus 4ac is, then I allow you to skip straight to this. This can be reduced nicely. 32 is 16 times 2. So this ends up being 8 plus or minus 4 root 2 over 16. Everybody got this okay so far? Yep.
Why is it 8 and not negative?
Because the b was already negative, and the formula is negative b, so when we put the negative with the negative, right? 2 negatives makes positive. Now, remember this. Some people try to do this, but when you're adding on top, you can't. So if you are reducing, you've got to reduce from all 3 parts, this part, and this part. It's got to be all 3. But they can all be divided by 4. So 8 divided by 4 is 2. 4 divided by 4 is 1, so plus or minus 1 root 2. And 16 divided by 4 is 4. Is that what you were going to say earlier, that it can be reduced?
Yeah.
Yeah. You don't have to do this, because we're just going to punch this into our calculator anyway. If you have a calculator that does this for you, this is easier to type into your calculator without making a mistake. It's less writing. But it's up to you whether you want to bother reducing it or not, because this is not a final answer. Obviously, if it was a final answer, it would have to be fully reduced. Not a final answer, so we don't have to. Okay? Any questions about this so far? This is still just sine x equals. So what do we do next? Let's do this. So therefore sine x, let's do this first, equals 2 minus root 2 over 4. And sine x equals 2 plus root 2 over 4. What do we do next? What do you think?
You get rid of the sign by doing the inverse of something, the 2 minus or plus root 2 over 4.
Good. So now this is obviously, I hope, not an exact value question. If it was sine x equals a half, then we'd be using the triangles to get x related. But we can't do that, so these are a calculator question where we're doing inverse sine or shift sine to get the answer. But there's actually something we want to do before that. Can anybody think of why there might be something else we want to do before putting it into our calculator? Something we want to do first, and there's 2 reasons why.
Can you reduce the 2 and the 4?
No, because remember, it's got to be from every part. So I can't just reduce 2 parts and leave 1 part alone. Andy?
Is one of them extraneous?
How would we know if it is?
I don't know.
Well, yeah, but you're right. Didn't that happen yesterday where it's not that it's extraneous, but there's no solution? So how could we find out if that might be the case? So that's one of the reasons why we want to do the next step.
If the top part is larger than the bottom?
Okay, so in other words, we want to evaluate these. So fraction 2 minus root 2 over 4. And we need the decimal. 0.15. I don't need to keep 4 decimal places. I'm not really doing anything with that. I just need to know what it is. And then I can go back in. Plus. So in this case, it looks like they're both going to work. But it's possible that one of them would be outside the range of sine, and so there would be no solution. There's another reason why we need to do this. Anybody think of what that is? A hint would be thinking about what we're going to do next after we get x related.
Do we need the value because we're going to put it into the equation and then we need to round it to 4 decimal places?
Not exactly, because we're going to do a lot of that work just with our calculator and only kind of round at the end. Evan? We need to know if it's negative or positive to find which quadrant it's in. When we get x related, then the rest of it is quadrant stuff. And if I don't even know if this is positive or negative, when I'm looking at it like that, sometimes you might be able to tell, but sometimes it might be kind of hard to tell if it's going to be negative or positive. So the easiest thing, and again, there's 2 reasons, we want to know what that decimal value is. So, just quickly put it into your calculator, and then we're going to move on. So x related equals, now I'm going to go back up to this one. Whoops, not that one. This one, I guess. 0.1464. It was positive. Sine, so we're in quadrants 1 and 2. And shift pi minus answer. No, wait a minute. What am I doing? I skipped a whole step. Is that what you're going to tell me? Oh my goodness. Maddie, what did I do wrong?
You did it with the inverse.
I didn't actually do the inverse goes part. Okay, sorry about that. So I got to go back up here and get this. Here, I'll just do it like this. Shift, sine. Now, some people were having problems with brackets in the previous class. So if you're not getting the right answer, you should be trying these on your calculator. It's the best thing to do to make sure that you get the same answer as I'm going to get right now. Try it on your calculator. If you're not getting the same answer, I can help you out with that later. And it's probably a brackets issue. If you have a fraction button like this, it's the safest way to do these. Over 4. There we go, 0.1470. And now, I can do pi minus answer. There we go, 2.9946. Yep.
Do you want us to have the equals approximately symbol there?
Every time you round, you should be using that symbol, yeah. And that's rounded. That's kind of just rewritten, so I don't know if you would call it rounded, but that one is certainly rounded, so I'm going to use that symbol, yeah. Okay, and then again, x related equals shift sign to plus root 2 over 4. And they're both positive, so they're both quadrants 1 and 2. Any questions? So that's the only thing that's new for this first lesson is just quadratic formula. All the ones yesterday were factorable, but now maybe some will be factorable and some won't be. So that's the only new thing we're adding. We're going to do one more. Questions? We're good? Okay. What do we notice about this one? Yeah, what do you think?
It has a cos and a sine squared.
Yep, it's got cos and sine squared. And what else? That's just kind of a small detail. Maybe it's obvious, but go for it.
It doesn't equal 0.
Yeah, it's not like really set up. Like sometimes, again, when we were doing polynomials, sometimes we isolate. Sometimes we move everything to one side and let it equal to 0. Quadratic ones are the type where we're always moving things to one side and setting it equal to 0. So let's do that. Let's get everything on one side first. Negative 2 sine squared x plus 10 cos x minus 1 equals 0. And now we can notice that this is not factorable, and not because of the quadratic formula stuff, but it's not factorable because I have like an x and a y, right? You can't factor that when you've got different trig ratios involved. So what do you think we're going to do?
Just a question.
Yep.
I know right now we put the sign first because it's squared, but if they were both squared or both not squared, would it matter which order we put them in? Or?
It really doesn't matter which order you put them in at all right now. At the end, right before we factor, we want it to be in the right order. But
Okay.
Up until then, no, it doesn't matter. You would want to have them all. You need to have them all on the same side, I think, before you start doing next steps. But Zach? Very nice. So we did this yesterday. It's a swap out. So this one's got a swap out, and it turns out it's going to be quadratic formula. The one we did in class was, I think, cos 2x, and we swapped it out. But in the practice, I know that there are some like this, and I said, sometimes you're going to use the Pythagorean identities instead, so that's one of these. And people do have questions like, well, how do I know which one to change, or how do I know to change it to cos or change it to sine? Well, you can't. We don't have an identity for just cos. The only one we have is for cos squared or cos 2x. So there's really probably only going to be one term in the question that can be swapped out. So you have to know the identities well so that you recognize it and you figure out how to swap it out. This negative 2 is important because now it's going to distribute in. And now I'm going to put it in the right order. 2 cos squared x plus 10 cos x minus 3 equals 0. Next step. Okay, but before that, I mean, I already gave it away that this is, but what would we do if we didn't know that that's how it was going to work out?
You figure out what b squared minus 4ac is.
Good, so we want to check b squared minus 4ac. Do you know what it is?
I got 124.
Sounds right to me. 124. I'm not going to this one, these ones reduce as well, but you know, this time I'm not going to bother because we don't have to. And if your like I said, if your calculator does it for you, maybe you reduce at that step. It's less writing. Okay, so we want to figure out what this is, what each of these actually works out to. This one's negative 5.28. So no solution. It's outside the range. It can't be bigger than 1 or smaller than negative 1. Somebody asked this morning, so all negatives have no solution? No, not all negatives. It's got nothing to do with the fact that it's negative. It's the fact that it's a negative value that's smaller than negative 1. Okay? This one works out to 0.28. So it's positive, and it is within the range, so it's going to have solutions, but it's positive, so that we don't have to worry too much about that. Folks, if it was negative, this is a little bit tricky. Okay? So listen carefully for a moment. If it was negative, you have to put it into your calculator. When we put it in our calculator, we drop the negative. How do I drop the negative when that's what I'm putting into my calculator? Well, you got a couple of ways of doing it. You can just stick a negative out front of the fraction, because that'll take that fraction, which in this case isn't negative, but like in some cases it will be, and it'll flip it back to a positive, but it'll leave everything else the same. Don't put the negative in the top. You can't just make the negative, the 10 negative. It's got to be all the way out front. Or when you get this answer, do shift cos negative answer. Because if the answer is negative and you put a negative out front, now it'll be positive, but it'll be the same value. Okay? If you're not sure what I mean, when you get to the practice, make sure that you're using the solutions or whatever to check that you're getting the right related angle. And if you're not, it's probably a calculator thing, and it's probably because it's negative or something like that. And or if you don't understand exactly what I'm talking about, you can ask me about it after. We can go back over it. So x related should be 1.2830. And now we're going to quadrant 2. So it's 2 pi minus that answer, 5.0002. Yeah.
So is it just, it can't be bigger than 1 and smaller than negative?
Right.
I thought it did an answer.
Did you?
My x-related thing, but I don't know why.
I can come and look. Sometimes it's brackets around that fractional part.